Hello everyone. Welcome to the webinar. So today I'm going to talk about integration. I have made at least 4 webinars on integration, back and forth, different areas. So today I'm going to focus on integration skills. So we'll only be doing indefinite integrals, using different methods. So I'm not going to do Riemann today, and then I'm not going to do integrals with limits. Yes, so with top and bottom limits. So if you want to see those, please go back to my previous webinars where I go through everything. But today I really want to focus on integration. The reason I want to do that, integration is a very complex thing. It can be incredibly complex, and you will see some of the integrals that we are going to do today really require some ingenuity. So we had this diagram a few weeks ago where differentiation is just the 4 rules, or 3 in fact, and integration is crazy. Okay. So today we're going to talk about, well, none of these actually. Yeah. Oh, okay, sorry. We're going to do integration by parts, and we're going to do substitution. All right, so so if it doesn't work, then yeah, we're in trouble. But mostly they will be done. So the methods that are available to you, so integration by parts, substitution, and before everything, it's the simplifying. So transforming, forming the function that it looks, or breaking it down into integratable functions. Yeah. So that's what we're going to do with the first one. So with differentiation, it was super easy. If you have uv dash, it's u dash v plus uv dash. There's no such rule in integration. When you had a derivative, so u over v, derivative is u dash v minus uv dash over v squared. There's no equivalent in integration. Okay. For integration, so this is differentiation, dy dx. In integration, no equivalent. No equivalent. And the chain rule, f g of x dash is f dash g multiplied by g dash x. That's the chain rule. There is an inverse chain rule, but it is very limited rule. It's very limited. So in most cases, to solve products, or when you divide two functions, you have to use either substitution or integration by parts or transforming the functions, right? So that's why integration is so difficult. There's no equivalent for these rules. And even when there is one, it's incredibly limited. Anyways, let's go with this one. This is quite easy, actually. It looks complicated, but actually it is not. Well, first of all, it's multiplication. We don't know what to do with multiplication. There's no product rule for multiplication. Therefore, we have to break it down. Okay, so, well, this can be written as x to the power half. So first of all, we write mod root x times x. So that's root x times x to the power half, which is x to the power 3 over 2 to the power 1/2. So that's x to the power 3/4. So we have integral 1 minus x to the power minus 2 and multiplied by x to the power 3/4 dx. Oh, now it looks reasonable. It's going to be x to the power 3/4 minus 2 minus 3/4. That's going to be x 1 minus 5/4. If I make a mistake, please let me know. Dx. And now I can integrate. I can integrate them separately because I can integrate this bit, 3/4 dx minus integral x minus 5/4 dx. Now this I can do. So I know that the integral of x to the power n dx is x to the power n plus 1 over n plus 1 plus c. Are you familiar with the basic formulas? I hope so basic integrals. Is everyone familiar with the basic integrals? Oh, on a scale of 0 to 10, please let me know. Do I need to recap? Okay, so I don't need. Okay, good. Good to know. So you are doing the basic integral. So we have the x to the power n. This only works when n is not minus 1. If n is minus 1, it's a separate integral. It's 1 over x dx. That's logarithm modulus x plus c. Third integral of sine is cosine. So minus cosine, and integral of cosine is minus sine. But anyways, this I can do. That's x to the power 3/4 plus 1. So 7/4 over 7/4 minus x to the power minus 1/4, because minus 5 over 4 plus 1 divided by minus 1/4 plus c. And you can just like cosmetic changes here. That is 4/7 x to the power 7/4 plus 4 x to the power minus 1/4 plus c. That's it. So this is quite simple. This is very straightforward and very simple. Moving on to this one. This is where we need to talk about that ingenuity. Now, I do have to do a disclaimer. I haven't done these integrals before. So if you see me stuck, that might just as well happen. I might get stuck. But hopefully not. So this I see this. So my guess is that we would multiply top and bottom by √1 plus x squared minus √1 minus x squared. Top and bottom. Okay, let's see what we get. So on the top, we get 1 plus x squared minus 1 minus x squared. That's very beautiful. On the bottom, I get 1 minus x to the power 4, open bracket. I don't think that works. Well, how can you square it? No, you can't just square it. Okay, let me see. So 1 plus x squared minus. No, that won't work. No, sorry. I do. You do want to square it. Let's see. Can you rationalize the denominator? Well, that's effectively what I was trying to do. The problem is you don't really get anything beautiful here. Okay, I noticed that if you square the top, you get something very similar to the bottom. So I'm just gonna write out 1 plus x squared plus root 1 minus x squared, and I'm gonna square it, and it's going to be 1 plus x squared plus 2 root 1 plus x squared 1 minus x squared and plus 1 minus x squared. X squared cancels and I get 2. So I get 2 plus 2 root and 1 minus x squared minus 1 plus x squared, that's 1 minus x to the power of 4. Okay. So what can I do with it? What do I do with it? Well, I can say that the bottom integral is square minus 2 over 2. I think I need a substitution here. Apology, I did not expect to be stuck on the first one. Let me just have a think about it. You know what? Let me get back to this one. I apologize. I'll be back. I'll be back. Okay, so let's jump to problem 3. Now, where was it? 1 minus sine 2x. Okay. So, wait a second. Which section was that? Okay, so I can, it says from 0 to pi. I can do 1 minus 2. No, that won't work. Let's say what if I do sine 4x can be written as 2 sine 2x cos 2x. That's inverse chain rule. The inverse chain rule is so where do you see the inverse chain rule here? Okay, I don't think that works. So let me see if I can do something else. What if I do 1 sine 2x is equal to the square root of 1 minus cos squared 2x. That doesn't help either. Do I substitute? This is really embarrassing. Okay, let me. These two are these two are difficult. I'll get back. I'll be back with this one as well. Okay. Right. This one. This is a substitution one. So I'll demonstrate how to do a substitution. And yeah, it's really difficult to do integrals on the go, especially. Hopefully, I managed to demonstrate that. So this is an integration by substitution, and I'm going to substitute this bit. So I'm going to say it's a substitution, and u is equal to 8x cubed plus 27. I immediately differentiate, so I find du dx, and that is 24x squared. And from here, I can express, well, let's say dx. I can express dx, and it's du over 24x squared. So I make dx the subject, and then I can substitute. So when I substitute, I get integral of x squared. So that is, well, x squared. Dx. Dx is du over 24x squared over u to the power 2/3. X squared cancels, and I get 1 over 24 u to the power minus 2/3 du. And this is an integral. This is a basic integral. So 1 to 24 u to the power minus 2/3 plus 1 over minus 2/3 plus 1 plus c. So that is 1 over 24 1/3. So that's 3 on 24 u to the power 1/3 plus c. So that's 1/8 cube root of, what was it? 8x cubed. X cubed plus 27. 27 plus c, and that is the answer. Okay. So Serena, you can't just square a fraction. Like a over b is not the same as a squared over b squared. So root a over root b is not the same as a over b. So you're not allowed just to square things. Unless it's an equation where you can, because you're squaring both sides. Okay, this one. So I have 3 integrals here. They look quite similar, but they are done in completely different ways. Well, at least the last 2. So to demonstrate this integral, I can do, so what can I do here? It's sine to the power 5 cos x. I do a substitution. And I make u equals to sine x. And then du dx du dx is equal to cos x, and that means that du can be expressed from here as dx. No, I don't need du. I need dx. because I need to replace dx. Dx is du over cos x. And when I do that, I get integral u to the power 5 cos x multiplied by du over cos x, and you can see that cos x disappears, and I get the integral of u to the power 5 du, which is u to the power 6 over 6 plus c, which is 1/6 sine to the power 6x plus c. So the rule is if you have an if you have an odd power of cosine x, so so if you have sine to the power n x cos m x dx, so if you see integrals in this form, so if n plus m is even, you must do a substitution. Either u equals cos x or u equals sine x. Now, if n plus m is odd, then you have to use power reduction formula. Reduction formula, as I shall demonstrate. So first, let's do the first one. This is even, so a substitution will suffice. So it's vice versa. Apologies. So why was I looking here? So if it was sine, okay, I'll just do the integrals. So here, I can't really do a substitution because if I substitute cos x, then I will have cos cubed, and I wouldn't know what to do with cos cubed. Okay, so let's do them in the opposite order. Let's do the cubed first. So here I have to use substitution. So substitution. And I substitute u equals cos x. You will see why in a second. So I dy du over dx, and that's sine x. And that means dx is equal to du over sine x. So you do that, and that becomes integral sine cubed x du over sine x. Sine x cancels, and I get integral of sine squared x du. What do you think I can do with sine squared x for it to become in terms of u? What's sine squared x in terms of u? Has anyone noticed? Oh, you could do that. 1 minus cos. It's 1 minus cos x, cos squared x. Yeah, yes. Cos squared x, which is u. So that is integral of 1 minus u squared du. Perfectly reasonable integral, which we know how to do. It's u minus u cubed over 3 plus c. which becomes cos x minus 1/3 cos cubed x plus c, and that is the answer. So let's modify this rule. Sine x to the power dx, or integral of cos n x dx. If n is even, no, if n is odd, it's substitution. If it's even, you need to use a power reduction. So this integral looks very similar to this one, but you can't use this rule for, you can't use the substitution for this integral. So you have to use power reduction. So how do you use power reduction? Well, we know that sine squared x is, well, we know 1 minus 2 sine squared x is cos 2x. Therefore, sine 2 squared x can be written as 1 minus cos 2x, 1/2 minus 1/2 cos 2x. And that's what we're going to do here. We're going to say it's so power reduction formula. So why is it called power reduction formula? Because sine squared x becomes cos 2x without a square. So that means we have the integral of 1/2 minus 1/2 cos 2x squared dx, because that's sine squared x. Now we expand. It's 1/4 minus 2 times I got, so 1/2 cos 2x plus 1/4 sine, so cos squared 2x dx. Now the first two integrals we can calculate. Now the third one we have to use power reduction formula again. So cos squared 2x is equal to 1/2 plus 1/2 cos 4x. So we substitute that in. So we get the integral of 1/4 minus 1/2 cos 2x plus 1/4 times 1/8 plus 1/8 cos 4x dx. And now you can, in fact, integrate that using the inverse chain rule. So 1/4 plus 1/8, that's 3/8. So that's 3/8 x. Then minus 1/4 sine 2x. Then integrating this bit. And now integrating this bit is 1/4 times 1/4. That's plus 1/32 sine 4x plus c. Phew. So, bottom line, even when you have two incredibly similar looking integrals, they can be done in two completely different methods. That these methods do not even overlap. Okay, integration for you. So hopefully, yeah. How well did you understand both? Well, let's do the substitution. How well did you understand the substitution method on the scale of 0 to 10, please? Okay, how well did you understand the power reduction formula? on a scale of 0 to 10. Okay, so less confident here. Okay, let's do another simple integral. So when you do integral of sine squared x, that's the simplest even power you can get, except 0, of course. So I'm just going to remember that cos 2x is 1 minus 2 sine squared x. So from here, sine squared x equals 1/2 minus 1/2 cos 2x. I'm just rearranging this. So this is the power reduction formula for sine, and I'm going to use that. So it's 1/2 minus 1/2 cos 2x dx. Now I'm going to integrate because I know how to integrate this. It's going to be 1/2 x minus, so integrating this is going to be 1/2 times 1/2, 1/2 times 1/2 times sine 2x plus c. So that is 1/2 x minus 1/4 sine 2x plus c. I hope that makes more sense. So, okay. Now, coming back to this one, here, well, it's very convenient because you have cos x. It's an odd power. How can we expand this rule? Is both of them are odd, if m and n are odd, then you can use substitution. Okay. Now, this one really requires some ingenuity. Okay. So I'm going to do a substitution here. Oh, no, actually, I'm going to simplify it first. Before I do any substitution, I'm going to simplify. I'm going to say sine squared x plus cos squared x. That's equal to 1, right? I'm going to square both sides. So that makes it sine to the power 4x plus 2 sine squared x cos squared x plus cos to the power 4x. And that's equal to 1. From here, I can say that sine to the power 4x plus cos to the power 4x can be written as 1 minus 2 sine squared x cos squared x. And that I'm going to write here. It's going to be sine x cos x over 1 minus 2 sine squared x cos squared x dx. Okay, that's already better because we don't have any cosine fourths anymore. Now I can use the double angle formula. I will say that sine 2x is equal to 2 sine x cos x. And that means that this is a half integral of a half sine 2x. And here, this is going to be 1 minus a half sine squared 2x dx. And right here, don't ask why, but I think we need to do a substitution. So substitution. And the substitution is u equals cos 2x. You'll see why in a minute. So once again, this is so u is cos 2x. So what gave me a hint? I have sine x. I have an odd power of sine. So that gives me a hint that I should use substitution. Because if I find du dx, there's going to be 2 sine 2x. That means that dx can be expressed as du over 2 sine 2x. And that means that my integral becomes 1/2 sine 2x multiplied by dx, and dx is du over 2 sine 2x. Aha, sine 2x disappears. And now here I have 1 minus 1/2, and I know that sine squared 2x, that's 1 minus u squared. I've managed a substitution. So I'm just clear things up. So 1/4 du over 1 minus half plus half u squared. So that's 1/4 goes out. Integral 1 minus a half, so a half plus a half u squared du. So it's a half integral du over 1 plus u squared. Lovely. And we know that this integral is arctan. So it's 1/2 arctan of u plus c. Ta-da! And now just do a reverse substitution. So half arctan cos 2x plus c. Arctan cos 2x. It must be something. It must be something really easy. But I'm not going there. I'll just leave it as it is. It's perfectly acceptable. So looking back, well, I had to notice that this thing is actually linked to this. Then I noticed that this is a double angle formula. And then I then I saw that sine is the derivative of cosine, and that is why I used the substitution what u equals cosine 2x. I differentiated it, and now it goes here, and then the sine goes away. I knew that. I knew that this is going to happen, and that's how I did this integral. Okay. So this is called this textbook is called Demidovich. Demidovich. Oh. Demidovich. Yeah. Okay. This one. I think this is fairly straightforward. Let's see if I can make a substitution. So let's say u is equal to 1 plus e to the power x. Du dx is e to the power x, of course. So dx is du over e to the power x. And e to the power x is actually u minus 1. So du over u minus 1. Would that make any sense? Not necessarily. Root u. Maybe I can do better. Or perhaps not. Okay, let's see where this takes us. So integral du over u minus 1 square root of u. Okay. Now I do another substitution. W is equal to square root u. Dw du. This is 1 over 2 square root u. So du over square root u can be replaced as 2dw. Okay. And u is equal to w squared. Ooh, that is beautiful. That is a beautiful integral. Okay, let's see. It goes integral du, which is du over square root u. So this thing is just 2dw, 2dw. U minus 1, that's w squared minus 1, minus 1. Aha. And here, okay, w squared minus 1. So here we need to use something that is called partial fractions. So I'm going to write 2 over w squared minus 1. And I want to simplify this. To simplify this, I factorize the denominator. Plus 1, 2. And I know that this can be written as a sum of two fractions, w minus 1 plus b over w plus 1. So this is the partial fractions method. Partial fractions. And then we can find a and b. To find a and b, I make the I find the common denominator. So w plus 1, w minus 1. So aw plus a plus bw minus b over w minus 1, w plus 1. And from here, I know that a plus b must be 0 because there's no w here. Like this is 0w plus 2. So the a plus b must be 0. And a minus b must be 2. So a is 1, b is minus 1. That's the only solution. And therefore, this fraction can be written as 1 over w minus 1 plus 1 over w plus 1, sorry, minus w plus 1 integral dw. And we know how to calculate the integral. So the first one is logarithm modulus w minus 1 minus logarithm modulus w plus 1 plus c. Sorry for making such a mess here, but let's now do reverse substitution. Logarithm of square root u minus 1 minus logarithm square root u plus 1 plus c. And now square root u is 1 plus e to the power x. So that's logarithm. I can combine the two logs into 1. And the square root of u minus, okay, square root of e to the power x plus 1 minus 1, square root of e to the power x plus 1 plus 1 plus c. And that is the solution. Okay, that's a very beautiful thing. When we do negative, you might be right. You might be right. Yes, minus, minus, minus. So that's minus. Yeah, so it's minus, minus. Thank you. Somebody mentioned that I missed a minus, of course. Thank you. Thank you. I've changed that. Okay, so let's go. I'm kind of dreading going back to the first one. Let's see if I can tackle this one. I didn't worry about it because it was in the section of the simplest integrals. It was in the chapter labeled simplest integrals, and I was like, yeah, that's going to be simple. And then suddenly, so let's look at it from with fresh eyes. I think if I can sine 2x. Is 2 sine x cos x. So what if I do a substitution? I shouldn't need to do a substitution here. U is sine 2x. What if I use u is equal to 1 minus sine 2x? Then du dx is going to be minus 2 cos 2x. Dx is du over minus 2 cos 2x. And that doesn't really help me, does it? Cos 2x is equal to 1 minus sine squared 2x square root 1 minus sine 2x. Sine 2x is 1 minus u squared, so square root of 1 minus 1 minus u squared square root of 1 minus 1 plus u squared. No, sorry. 1 minus 1 plus 2u plus u squared, which is square root of 1, square root of 2 minus 2u minus u squared. Does that even help me? Integral of square root of u multiplied by dx, which is du over minus 2 multiplied by square root of minus 2u minus u squared. I think it does. So square root of u over minus 2 square root of minus 2u minus u squared du, and that is square root of du over minus 2 square root of minus 2 minus u. Okay, I can integrate that. That looks wrong, but it's going to be minus 1, so it is minus u minus 2 to the power minus 1/2 integral du. So that's minus 1/2 multiplied by minus 2. No. Multiply 1 over minus 1 multiplied by minus u minus 2 to the power plus 1/2 divided by 1/2. So 1/2 cancels, the minus cancels, and plus c. So that is square root of minus u minus 2 plus c, and that is minus u square root of minus 1 plus sine 2x plus minus 2, so which is plus c, which is square root of sine 2x minus 3, which doesn't make any sense because you can't have square root of a negative number, and sine 2x minus 3 is a negative number. Where did I go wrong? This is minus. This is minus, so this is plus 2u. Okay. Plus. So that's not a plus. This is a minus. This is minus plus. And this is u, so plus 1 minus 2. So minus 1 plus c. Better, but still a negative number. So let's see if we can differentiate that. Okay, let's double check. So in order to check this, cos 2x, because that's the main trigonometric identity. So cos squared 2x plus sine squared 2x is 1. That means cos squared 2x equals 1 minus sine squared 2x, and then you take the square root. Well, technically it's plus minus, but it's from 0 to 2 pi, so I just assume that it is plus. I think I have a better solution. Bear with me. So I think I have a better solution. It must be something simple because it is from the section of simplest integrals. So I'm going to rationalize, and I'm going to multiply top and bottom. Multiply by square root of 1 minus sine 2x. So multiply top and bottom by this. What do I get? I get integral of 1 minus sine 2x. Ooh, I think I need to multiply by plus. So I root this, multiply by root 1 plus sine 2x, divided by 1 plus sine 2x dx. Okay, let's see if we can get somewhere. That's integral. This is square root of 1 minus sine squared 2x. Ooh, divided by 1 plus sine 2x dx. That is clever. Okay. Okay. So this is cosine. So this is cos 2x. Because 1 minus sine squared x is cos 2x, cos squared 2x, and square root of that over square root of 1 plus sine 2x dx. And now I do my magic substitution. Substitution. U equals sine 2x, and that means du dx is 2 cos 2x, and dx can be written as du over 2 cos 2x. And now I write that integral of cos 2x multiplied by dx, which is du over 2 cos 2x, over 1 plus u, up. So it's 1/2 integral of du over square root of u plus 1. Now, I'm going to do a trick. You can do a substitution, but I'm going to do a trick. I'm going to say this is 1. So can I do this trick? No, I don't need to. Sorry. I don't need to do any tricks here. It's literally just the integral of u plus 1 to the power half du, which is 1/2 multiplied by u plus 1 to the power 3 over 2 over 3 over 2. So 2 cancels, plus c. So that is 1/3 square root of sine 2x plus 1. Oh, I don't need that. 1/3 sine 2x plus 1 to the power 3 over 2 plus c. Good. And yes, thank you. Minus half. 1/2. 1/2. 1/2. So just that. Square root. So that is the square root of sine 2x plus 1. Sorry, plus c. Ooh, interesting. The derivative of 1 minus sine 2x is 1 plus sine 2x. Oh, sorry, the derivative of so sine 1 plus sine 2x, that's the answer. Let's differentiate that. And they say it should be equal to that. It's going to be 1 over 2 square root of 1 plus sine 2x multiplied by cos 2 cos 2x, 2 cancels. And we indeed see that cos 2x over 1 plus sine squared 2x is square root of 1 minus sine 2x. Okay, that is very clever. Right, so I wouldn't even look here. So this is the solution, and a good one for that. Now for this one, I have a hunch that it's a very similar method. You do it using a similar method. I just need to figure out which one to do. So square. Difference of two squares in the denominator. I can. Yeah, let's do that. So it's the integral of square root of 1 plus x squared plus minus x squared. So here I have square root of 1 plus x squared multiplied by square root of 1 minus x squared dx. I can divide top and bottom. You can divide top and bottom by square root of 1 minus x squared. Let's see. I get square root of 1 plus x squared over 1 minus x squared plus 1 divided by square root of 1 plus x squared. No. No. Ooh, that is beautiful. Now I can break it into two fractions. The square root of 1 plus x squared over square root of blah 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 plus square root of 1 minus x squared over square root. So break into two fractions. Okay, I was looking for something complicated. It's actually not. So as I said, it was in the simplest. Okay, I think I managed not to embarrass myself completely today. So that would be integral of 1 over square root 1 minus x squared plus 1 over the integral 1 plus square root of x dx. And both these integrals are table integrals. I don't remember them, but let's look them up. So standard basic integrals. Here it is. So this is arc sine. This is arc sine, and the plus one. Why is it not given? Arc sine. Okay. Right. So the first one is arc sine x plus. So this is supposed to be log, well, ln. Is there a difference? Log. Should be natural log. Log x plus square root of x squared plus 1 plus c. No, arctan is when there's no square root. When there is a square root, it's not arctan. Let's differentiate that and check. Logarithm x plus square root of x squared plus 1. Let's differentiate that. That's going to be 1 over x plus x squared plus 1 multiplied by 1 plus 1 over 2 square root of x squared plus 1 multiplied by 2x 2x. So that is simplifies to 1 over x plus square root of x squared plus 1 multiplied by square root of x squared plus 1 plus x over square root of x squared plus 1. Oh yes, it does. So it is true. I wonder why they used... I wonder why the formula has log instead of ln, but anyways, I mean, not everything you read on the internet is true, right? Okay. Or maybe it's to do with the constant. Good. So hopefully that makes sense to you. Sorry for making a mess here. So that is checking this integral, and this is the solution. This is the solution. So I will round the solution in every single one of them. So this is the solution. And for this one, that's here. That is here. That is here. That is here. And that is the solution here. That is the solution for this one. Why is it not doing that? And this is the solution here. Okay. Finally, we get to integration by parts. Integration by parts is a consequence of the product rule. If we write down the product rule, product we can write it as the derivative dx of uv is equal to du dx multiplied by v plus u multiplied by dv dx. Okay. Now, if I make I can write u dv dx as d dx uv minus v du dx. And now if I integrate both sides, so integrate, integrate, and integrate, I get the integral of u dv dx do I multiply by dx? Yeah, I integrated with respect to dx, of course, and then that is dx and equals, well, the integral is the opposite of differentiation. So here we have a derivative of uv. So if we take the integral, that's going to be just uv, funnily enough, minus v du dx. So this is the integration by parts formula. This is the horrible way of writing it. So let's do it in another form. So uv dash is equal to u dash v plus u v dash. And here we can say u v dash is u v dash minus u dash v. So I've rearranged that. Now I integrate. Now the integral of with respect to dx, of course, dx, and we know that the integral is of uv dash is just uv. So the integral of uv dash dx is equal to uv minus u dash v dx, and that's it. That's the formula of integration by parts. Integration by parts. Integration by parts. So the hardest part is to decide which one is u, which one is v. And I do trial and error. There are some rules which you can use, but I do it using trial and error. So okay. So I see this integral. It consists of two parts. It's a multiplication of 2. I can't really integrate that. But let's start to substitute. So let's say that u is equal to x and v is equal to e to the power minus x. That means v dash is e to the power minus x. U dash is 1, and v, we kind of do the opposite of differentiation, so we integrate v. So that's minus e to the power minus x. Okay. So this is u, this is v dash, and this should be equal to uv minus integral of u dash v dx. So the integral of x e to the power minus x dx must equal to uv, so that's x multiplied by e minus x, minus integral u dash, so that's 1, multiplied by v, which is minus e to the power minus x dx. And this integral we know how to do. So minus x e to the power minus x plus integral of e to the power minus x dx. So that's minus x e to the power minus x minus e to the power minus x plus c. Done. Okay, second one. We need to decide what is u, which is v. I'm going to say that x is u again, and cos is v dash. So u is equal to x. That means u dash is 1. V dash is cos x. So that means v is sine x. So that's equal to uv, which is x sine x. So that's uv minus integral of u dash v dx. So minus integral of, actually, you know what? Sometimes we don't really need to write the dx. Well, we do need to write dx, but we omit them when using the. Okay, let's keep it for simplicity. X sine x minus the integral of u dash, so it's 1 multiplied by v, which is sine x dx. So that's equal to x sine x minus plus cos x plus c. Okay. Now this one is quite an unusual one. It's just logarithm x. Like, how is that a how is that a integration by parts? Well, actually, u is x. Sorry, v is x. V is x, and v dash is 1. So it's actually written as logarithm x multiplied by 1 multiplied by dx. So this is u, this is v dash, this is v dash. So u is logarithm x and u dash is 1 over x. And that's what we use. So it's uv, so it's x logarithm x minus the integral of u dash, so it's 1 over x multiplied by v x dx. X cancels and we get x logarithm x minus integral dx, which is x logarithm x minus x plus c. Okay, this is how to do integration by parts. So, sorry for rushing through this. Hope you found something useful today. If you found this too complicated, please go back to my other webinars. They are easier. And yeah, so hope you enjoyed today. I'll see you next week for some physics. And so webinars, what's next week? And next week is work, energy, and power. Oh, exciting topic. Okay, I'll see you all next week.